Welcome back to the second half of Fullerton College's pre-press classes, PIA 3.6, Digital File Problems and Solutions. This is Professor Ben Kiewit, and we're going to finish this out in only 2 videos today. Of course, now that I've said that, something catastrophically bad is going to happen. Here we go. When we last left off, we were looking at mostly font problems with customer files. This time around, we're going to start with image problems. I know we did talk about the ghost images, the low-resolution previews left behind as scant memories of what could have been. As in, the computer couldn't find the actual photo, so it sent that low-res preview because something's better than nothing. That's one thing. Now, if you get those files from customers and you relink them properly and the image is still low resolution, well, then you have a low-resolution image. That's one of the things that makes that one a little harder to diagnose and takes a 2-step process to figure out, because the first step is, do you even have it? Because most commonly, they just forgot to link it properly, or they moved a folder somewhere and it caused the image link to break so you don't get the full image. But if it gets sent and it's still bad, then it's low resolution. This typically happens when you use a picture that, actually not typically, scientifically speaking, the definition of this is the image does not have enough resolution or enough pixels in it for the size of the output. Every picture is high resolution if you make it small enough. It may be a postage stamp, but you can make it work. But to make the size people want, that's the issue. So here we go, looking at this again, you can see, I don't know if this video will show it accurately enough. I don't know the resolution of these videos well enough to tell you if it's going to look proper there. But on the left, you have a decent looking picture, and on the right, you have a blurry, jaggy, low resolution picture. So here's what we do with this. The Nyquist Theorem, which is still going on. You use this every day in your design programs. It's just built into the programs these days. But anyways, electrical engineer Harry Nyquist figures out the amount of signaling power to overcome the background noise during radio transmissions, because there's a lot of background radio transmission noise, and how much power do you need to be able to send a message what distance. The same theorem, though, seems to be used for calculating proper resolution. Hang on a second, my dogs are exploding. Sorry about that. My brave, brave dogs went and exploded at the front door because somebody was knocking. Anyways, we're back. So Nyquist, his theory also works to figure out the size of the necessary resolution for a picture at a given size. So you need to have 2 pixels of your computer pixels per halftone dot, which means it needs to be double the LPI, because halftone dots are in lines per inch, times 2 times the percent of the enlargement or reduction. In fact, I think that should be all our New Year's resolution this year. When someone asks you, what's your New Year's resolution? Well, it's double the LPI at the percentage of the enlargement. Of course. What other resolution is there? Anyways, that happens in Photoshop, that happens in InDesign, it happens in Illustrator. As you do these things, you can always just check through Photoshop to see if the size is the right thing. But that's how you know what the proper size can be. Missing bleeds. So here's one that's a little bit harder, that definitely requires your visual human inspection. There is no software that can determine if it's been done correctly. While your software, different pre-flight softwares like Acrobat and Pit Stop and Flight Check and all those other ones out there, they can determine whether or not there is bleed assigned to the file, but they cannot determine if it's been used correctly. In the same way that let's go here on this wild Ben analogy. Let's talk about cars for a second, and seatbelts, because seatbelts are important to keep us alive in case our cars crash or do anything weird, spin out of control, so we don't get thrown from the wreckage. And they've saved a ton of lives since they've started being used everywhere. However, the US government can put mandates out there. They can make regulations that cars being built must have seatbelts. So we know that every car sold in America has seatbelts in it. They're there. How do you know if anyone's actually buckling them? You have to actually check. If you get pulled over by the cops, you're not wearing a seatbelt, there's a ticket for that. But the point is, Having the safety, having it set up properly. Just because you have seatbelts doesn't mean they're being worn. Just because bleed space was assigned to a file does not mean that it was used correctly. And you need to visually check to make sure that the bleed is actually going proper. That means that the graphics actually extend off the page to the edge of the bleed area. That's something that you, the human, have to look at. The computer cannot determine if it's been used correctly, only if it's there. So that's on you. That's one of the things that we are kept around for. And it's one of the most common problems with digital files that somebody else makes. Get good at explaining bleed. If you get into pre-press professionally, you will spend a lot of your career explaining to other people what bleed is and why you need it. Trust me. So what do? You extend the graphic. If you have access to the working file, or if you get your client to do it, you just have them stretch that graphic past the edge. Scale that picture a little bit larger. Remember, it's 1/8 of an inch. That's the typical thing here. If you are over in any other part of the world, typical bleed is 3 millimeters, which is very close to the metric equivalent of 1/8 of an inch, if that's the size. That's how much you need, because that's about how much drift you'll get from page, not from one page to the next, but overall as printing shifts on paper and paper changes sizes from printing on a large press. We'll talk about that in another time, because it does. Don't assume that paper is all going to be the same size as when you started, because it's a physical object, it's organic, and it very much changes while you work with it. The materials of printing are one of the things that actually makes it tricky. But anyways, to account for all that, you have to make sure that the bleed is not just right to the edge, because even on our little lab, if we print something on a Xerox press and we only do 100 sheets, there's a chance that as you cut it, the top of the stack and the bottom of the stack are not exactly in the same place. The printing is not in the same place in the paper. So to account for that kind of slop, to account for miscalibration of cutting and just for somebody else doing your cutting, which is always scary, you need to make sure that you have enough bleed that if things move around a little bit, you're not going to lose that bleed and get white gaps on the edge of the page. So extend the graphic. Repeating elements do not align. This is more of a layout design problem, but you can see here the things like at the bottom, they have a red line across there. The footer, the buying power news is not aligned proper. It looks like the baseline of one is connected to the descender line of the other. Inconsistent color elements. Again, I don't know how good this video is going to show you the difference, but the circled things there with that kind of bluish grayish text, one of them is different from the other, and they should be the same, because that's going to look odd. And also, that's going to throw off more problems than you realize, or throw on more problems than you realize during output, because the people running the large offset presses who manually, many of you have worked with me on this in the past and have run the big Heidelberg in our lab, you know that you actually have to change the different ink densities across the page by opening and closing the ink well to allow more or less ink at different parts of the plate. So if you have something like this where one is a little bit different than the other, the press operators may assume they're supposed to be the same, and they may be compensating on their side to make sure they look the same. And by compensating to make them look the same, they may be overdoing one of the colors somewhere on the page where it doesn't. And then it'll start throwing off photos and other things that need accurate color. So trying to keep consistent things, well, consistent is a big deal. Image does not fit picture box. So sometimes the frame, as we know in InDesign, the image is inside a frame and the frame is not attached to the image, and the frame may or may not be the same size and proportions as the image. You could have a little gap. One of the easiest solutions to fix that problem that they're not talking about here, I mean, you can always enlarge it inside its frame to fit. You can look at how jaggy that is. I mean, seriously, some grade A JPEGery going on in this picture. But that little white hairline gap between the picture and its frame would not be there at all if you didn't put a frame around a picture. Current design styles that I've seen being used mostly these days, you don't put a frame around a picture, you let the picture make its own border just by ending. But if you need to have a frame, make sure you fill it proper. Catching the mistakes. So this is all things you look for during pre-flighting, which is what we talked about last week. Pre-flighting is looking for the problems, not necessarily fixing them, but looking for the problems so you can report on them to your client and let them know what's going to work and what's not going to work about their files. All right, well, this has been Digital Files Problems and Solutions. I hope it's been helpful. Sorry for the slight weird interruption in the middle of my video. But, dogs do what dogs do. All right. Until next time, guys,